Okay, so we're going to draw iodine pentafluoride. Iodine's going to be in the middle, and I'm going to draw the Lewis structure first, then we'll do VSEPR. So you know we're going to put our fluorines around the iodine, and that's 1, 2, 3, 4, and 5. And so putting our pairs, so the fluorines will have 8 electrons. There's 5 of them. So that's 40 electrons. We need 2 more. So those are going to go on the central atom. We'll put them there. So there's our Lewis structure. Of course, that doesn't show us the shape. So now I want to draw the valence shell electron pair repulsion model. So iodine's going to go in the middle, but I'm going to draw a little rectangle first. So that will help us. I'm going to do it in gray. This will just give us, so this is going to be the plane in which the four of the 5 fluorines are going to be. So I'm going to put the iodine in the middle. I'm going to draw a line straight up, and I'm going to put a fluorine here. Then I'm going to have a fluorine at each of these corners. And my pair of electrons is going to go right here. This is going to be a square pyramidal shape. Hopefully you can see that forming. And I'm going to draw my dashes going back into the plane from the iodine back to these fluorines. And then I'm going to draw wedges coming out. So if you draw that rectangle first, it gives you some perspective. So this shape is going to be square pyramidal. All right, so now we need to draw the box diagram. And I picked this one because I want to show it because we have these lone pairs, and I want to show how to draw with lone pairs. All right, so this is going to be, our central atom is going to be iodine. So this is going to be the 5s. This is going to be 5p, and then 5d. Of course, you know iodine does not have any d electrons. It's got 7 valence electrons, but we need to open up some parking spaces for the fluorines. Okay, so I'm going to go ahead and draw my 5d here. 1, 2, 3, 4, 5. My p's, these are going to be on the same level. And we're going to have iodine. We need to excite it. We need to promote some electrons. Now, if you look at our bonding scheme, we have a lone pair and 5 open spaces to bond. So not all of these are going to be promoted. So my 5s electrons are not going to be promoted, but they will be hybridized because they're part of that shape. On the other hand, the 2 p electrons are going to be promoted up to the 5d. Okay, so we're going to promote these 2. And we're going to get our 5d, and then we're going to have 3 5p electrons that are unbonded. So now we have space for the 5 fluorides. However, all of these are going to be hybridized. We need the lone pair as part of our shape, part of our hybridization. So even though they're not involved in a bond, they do get hybridized. And so the tricky thing is to know when to hybridize and when not to. But in this case, we get all of them. We're going to have 1, 2, 3, 4, 5 orbitals. I'm going to put those in between the P and the D. This is going to be S, so we have our S, 3 of our P's, so sp3 D2. So this gives us 1, 2, 3, 4, 5, 6. I said 5 earlier. It's 6 orbitals, not 5. 5 of them are going to be for bonding, but 2 of them are going to have electrons in it, so we're going to do that right there. So I need to add another one. So 1, 2, 3, 4, 5, 6, not 5. Okay, so then we have 5 unpaired electrons. And there they are. So you can see that our S went there. Those are going to be our non-bonding or unshared pair of electrons. And then we have 5 electrons ready for our 5 fluorine. So I'm just going to put 5 times fluorine. We're not going to show every single fluorine. We're just going to do it like this and show one of them and say times 5. Fluorine is a 2p, and you know there are 7 valence electrons or 5 electrons on the 2p. We're not showing the 2s, so we're showing the 5 of the 7 valence electrons, and then we're going to show 5 of these. Okay, so this one is going to represent all 5 of my valence electrons from fluorine going in here like that. So we've got our sp3d2 bonding, okay? So these are the bonding. Let's kind of draw that here. So these are my bonding, and these are non-bonding or unshared pair of electrons. So this is iodine in our bonded state. And then I'm going to draw the contour diagram in a separate video. But please remember that in this case, we hybridized all of the electrons, all the orbitals, of which there are 6. There's 6 orbitals. We've got to have these 2 that are going to be our non-bonding. That's those guys. And then the rest, the other 5, are going to be for bonding, but they are all hybridized in this case.